Welcome back to another video from my channel. In our last video, we discussed how we can calculate the mean, median, and mode from discrete frequency tables, and today, in this video, we will be expanding this idea to continuous, non-discrete frequency tables. For an example, we have this question: the length x millimeter to the nearest millimeter of a random sample of pine cones is measured. The data are shown in the table. Here we have a table consisting of the length of pine cone in millimeter and their corresponding frequency. However, there is a main difference between the ones that we did previously in our previous videos and this one, which is going to be the range of the lengths here. So before we try to solve this, let us establish some facts about the tables. If I draw another table to represent the data vertically, this is going to be the length in millimeters and this is going to be the frequency. For the first one, we have 30 to 31, then we have 32 to 33. Similarly, we have 34 to 36, and then 37 to 39. The corresponding frequencies are 2, 25, 30, and 13 respectively. Now, let us talk about these attributes of the table. So these are going to be classes, meaning that these groupings, for example, 30 to 31 is a class, 32 to 33 is also another class, then 34 to 36 is another class, and finally 37 to 39 is another class. Now, let us look at something that you call a class boundary. So the class boundary are going to be the endpoints of that specific class. For example, for the class 30 to 31, the class boundaries are 30 and 31, where 30 is the lowest boundary and 31 is the highest boundary. For the next one, 32, 33, 32 is going to be the lowest boundary and 33 the highest. The next one is going to be 34 and 36, and similarly 37 and 39. Moving on, let us talk about the class width, which basically describes the length of the boundary. So the length is going to be simply 31 minus 30 for the first one, which is going to be 1. The next one is also going to be 33 minus 32, which is also 1. The next one is going to be 2 because 36 minus 34 is 2. And the final one is also going to be 2. As I said, class width represents the length or the size of the class. Now let's move on to the questions. For number A, we have to find the modal class. Now, if you remember what modal is, it's basically a synonym to mode. And if you remember what the mode was, the mode is the group or the class with the highest frequency. So in this case, 34 to 36 has the highest frequency, which is 30. So the modal class will be 34 to 36. For number B, we have to estimate the mean. Now, if you look at the table, you're going to see that the classes are not connected. What it means is that the class boundaries are not same, meaning the highest is not the same as the lowest of the next one. So this means that we have to connect all of the class boundaries. And how would we do that is basically by establishing another table. So we will redraw the table again like this. And in this case, we're going to correct the class boundaries. So to correct the classes, what we have to do is that we have to take the smallest or the lowest boundary and subtract it with 0.5. And for the highest boundary, we have to add it with 0.5, meaning the new connected or corrected class will be 29.5 to 31.5. So we can write that being 29.5 to 31.5. And for the next one, which is going to be 32 to 33, which is this one, we have to also apply the same procedure. So we have to subtract 32 with 0.5 and you have to add 33 with 0.5, meaning the new boundary or new class would be 31.5 to 33.5. Now if you notice, the highest boundary of the previous class is now exactly same as the lowest boundary of the next class. So this is what we call correcting or connecting the classes. So this will be 31.5 to 33.5. For the next one, this will be 33.5 because 34 minus 0.5 is 33.5, and 36 plus 0.5 is going to be 36.5, and the final one will be 36.5 to 39.5, and this is our corrected or connected classes. Now we just write down the frequencies as before. So 2, 25, 30 and 13. So now we are done with connecting or correcting the classes. Now to find the mean, we knew that mean is equals to summation of x f divided by summation of f. Here we can find the value of summation of f easily, but in this case, because the values are continuous, this means we exactly don't know what value of that specific class will take. Meaning, the length here can be anything from 29.5 millimeters up to 31.5 millimeters. So we don't have a specific value for L. So in this case, what we have to do is we have to calculate the midpoint, which is going to be the value of x. So if you remember, the midpoint of 2 points A and B is going to be A plus B divided by 2. So in this case, the midpoint is going to be 29.5 plus 31.5 divided by 2, which gives us 30.5 here. And similarly, if you repeat this for the other values, for the next one, it will be 31.5 plus 33.5 divided by 2, which is 32.5. The next one will be 35, and the last one will be 38. Now we have found out the values of x. Now we simply tabulate the values of xf, which is going to be the product of x and f, the midpoint and their corresponding frequency, just like we did in our previous video. So adding another column, we have this. This is going to be xf. So 30.5 multiplied with 2 is going to be 61. The next one will be 812.5, then 1050, and then 494. And adding all of this together, we get a summation of xf values being 2417.5, and the summation of f's value being 70. Now you can simply use the formula of mean. So mean is going to be equals to 2417.5 divided by 70, which approximately gives us 34.5 millimeters. And this is our estimate of the mean for number B. And for the last question of number C, we have to find the median class. So if you remember from our previous videos, the median is going to be at the position of summation of f plus 1 divided by 2 position. So the median frequency is going to be summation of f, which is 70, plus 1 divided by 2 position, which is 35.5, meaning that it's going to be the average of 35th and 36th term. And in order to find the median now, we have to compute the values of the cumulative frequency, just like we did in our previous video. So this is going to be L, this is going to be F, and this is going to be the cumulative frequency or CF. Here I'm just using the not corrected one because it is going to be the same. So this has a frequency of 2, then 25, then 30 and 13. And the corresponding L values were 32 to 33, 34 to 36, and then 37 to 39. So for the first one, the cumulative frequency is going to be 2 because that is the initial frequency. For the next one, this is going to be 25 plus 2, which is 27. And the next one is going to be 27 plus 30, which is going to be 57. And for the final one, this is going to be 57 plus 13, which is going to give us 70. And if you notice, it is the same value as the summation of f. So now we can compare the values here. The median is going to be the average of 35th and 36th terms. So here in our cumulative frequency, the 35th and the 36th terms lie right after the class of 32 and 33. For example, 30 to 31 class has only two numbers, and after that we have 32 to 30, which has 25 numbers, meaning that the total is 27. After that, we have the class of 34 to 36, which had a frequency of 30 here. This means that after the 27 terms, there were additional 30 terms. So the total is 57, meaning that the 35th and 36th terms must lie right after 32 and 33. So the median class is going to be within the 34 to 36 class. And this is our answer. For the next one, in number 2, the noise levels at 30 locations near an outdoor concert venue were measured to the nearest decibel. The data collected are shown in the group frequency table. So we have a table here, and for number A, we have to calculate an estimate of the mean noise level. So let us tabulate the data here again in a vertical form, so that it's easier to find the summation of x, xf, f, and so on. And if you notice, this is range, and the class boundaries do not overlap each other, meaning we have to correct them again. So we have to subtract the lowest one, which is 65 here. So we have 64.5, and then we have to add the greatest boundary here with 0.5. So 69.0.5 and 65 minus 0.5. So this will be 69.5. Similarly, for the next one, 70 has to be subtracted with 0.5. So 70 minus 0.5 gives us 69.5. And this is what I meant by connecting them or correcting them. Similarly, 74 will be added with 0.5, which will give us 74.5. So it will be something like this. Then we have 74.5 to 79.5, applying the same correcting formula. Then we have 79.5 to 84.5, then 84.5 to 89.5. Similarly, we have 89.5 to 94.5. And finally, the last class is going to be 94.5 to 99.5. And this is the corrected frequency table. Next, we have their corresponding frequency, which is 1, 4, 6, 6, 8, 4, and 1. Now we have to calculate the midpoint, which is x being the midpoint. Just like before, we apply the formula a plus b divided by 2, where a and b are the class boundaries. So the first one will be 64.5 plus 69.5 divided by 2. So using a calculator, we find out the midpoints as being 67, then 72, then 77, then 82, then it's going to be 87, then 92, and finally we have 97. Now let's compute the values of xf here, multiplying both of them. This is going to be 67, then we have 288. Similarly, we have 462, then 82 multiplied with 6 will give us 492, then 8 into 87 will be 696. 4 multiplied with 92 will give us 368. And finally, the last one will be 97. So the summation of frequency is going to be 30, just like they have mentioned. But you can also check them out by adding 1 plus 4 plus 6 plus 6 plus 8 plus 4 plus 1, which gives us 30. And the summation for XF is going to be 67 plus 288 plus 462, 492, 646, 368, and 97, which is going to be 2420. So we have found out the summation of F and summation of XF. Now we calculate the mean, which is going to be the summation of XF divided by summation of X, which is 2420 divided by 30. So this will give us 80.7 dB or decibels. For number B, we have to explain why our answer to part A is an estimate. Now, this is an estimate because we have taken the midpoints like this, and we don't exactly know how the data is distributed. Here in this case, we are using the midpoint because we are assuming that all the data in each of these classes are uniformly distributed. So we assume that the classes are uniform or uniformly distributed, meaning that we don't know the exact value that the noise levels take. This is why this is an estimate. For the last math, the table below shows the daily mean temperatures in Addis Ababa for the 30 days of June 1 year. So we have temperature in range just like before and the frequency. Now you might look at the temperature and be confused, but don't be worried because they're exactly the same. For example, in this case, 20 is less than or equals to T is less than 22 is the same as 20 to 22. And if you notice, all of the class boundaries are connected to each other. So we do not have to apply the correction formula again because they're already corrected. So we can simply write down the temperature here as a table. So T, and then we can calculate the midpoint, which is going to be X. And then we have their corresponding frequencies, and then so on and so forth. So for the first question, we have to write down the modal class. And just like before, the modal class will be the class that has the greatest frequency. And we can see that this has the greatest frequency. So the modal class will be 16 less than or equals to T less than 18. For number B, to find out the mean, just like before, we have to find out the midpoint X and then multiply it with F and then find the summation of XF and then finally find out the summation of F and then use the formula. So for the first one, temperature is going to be 8 to 10, then 10 to 12, then 12 to 14, 14 to 16, 16 to 18, 18 to 20, and then 20 to 22. Now we can calculate the midpoint, which is going to be 9, and then 10 plus 12 divided by 2 is going to be 11. 12 plus 14, which is 26, divided by 2 is going to be 13. Then 15, 17, 19, and 21. Basically finding the average of these two. And the frequencies are 1, 2, 4, 4, 10, 4, and 5. We can multiply the corresponding X with their corresponding values of F. So this will be the table for XF, or rather the column of XF. So this will be 9, 22, 52, 60, 170, 76, and 105. So the summation of F is going to be equals to all of this, which is 30. Because as they have already said that there were 30 days of June, and similarly the summation of XF is going to give us 494, adding all of this together. Now we can simply find the mean, which is going to be summation of XF divided by summation of F here. So 494 divided by 30, which is simply going to be 16.47 degrees Celsius, or to three significant figures, it's going to be 16.5 degrees Celsius. And this will be the answer. Thank you guys for watching. Please make sure to leave a like, share, comment, and subscribe if you enjoyed the content. See you guys in the next video. Goodbye.